Am I on? Yes, I'm on. Good morning, everyone. So, I'm Clancey. Everyone calls me Clancey. My name's James. But I live in Anchorage, Alaska. It's kind of far away. But I like to go visit San Francisco regularly. I work directly for Nat, and so it's helpful to go into the office and meet with everybody. And our office is amazing. There's so many people there, and it's grown so much. And every time I go, I don't recognize half the people. So I like to go into the office, and I wish that was our view of the office, but the main office is in San Francisco, so I fly down and meet with everybody. And whenever I'm there, there's this couch in the office, and I've kind of claimed that as my desk. So anyone knows if they need to find me, go find me on the couch. And it's kind of nice because it's one of the traffic areas, so everyone walking by, I get to say hi and meet with people. Sometimes a little distracting, but it's quite nice. And Jay Frederick is one of our, what's he? There we go, customer success manager for enterprise. And I don't tell anyone when I'm coming to San Francisco. If I'm there, I'm on the couch. It's kind of just how you know if I'm there or not. Aside from Nat, no one else knows when I come in. So Jay walks by and he's like, wait, Clancey, you're here. And he's like, I'm going to a meeting and Batman needs your help. And I was like, you don't get that every day. So I'm like, all right, let's do it. Drop what I'm doing and run off to a meeting. And in the end, it turns out that people want to test games. Batman needs help testing. And how do you do that? People get into this thing that like you just can't do it, and who knows how to do it. They were planning on buying thousands of devices and having people manually test them. I mean, what do you do? And by the time the meeting was over, I realized we don't have a strategy for testing games in Test Cloud. It's just not something you can do yet. And it's something I wanted to fix. And I'm like, I want to test games. I'm guessing all of you do too. I wanted to test something fun, and it just seemed like a challenge. So I'm like, I'm going to do this. And we get back to the office, and I go up to Nat. I'm like, Nat, I'm going to test games. And shockingly enough, just like this dog, Nat's like, there's no way. You're not doing this. And I was like, really? I mean, I just got back. I want to test games. And I'm like, OK, if you're going to tell me no, I need reasons. Why? And these are some of the reasons they started giving out. Everyone thinks poor return on investment. When you think about testing a game, you're like, all right, we're going to put these images up on the screen. We're going to find the player, trace his outline, make sure he's not colliding with a wall. Think of Angry Birds. You're going to try and track the bird, make sure that he actually collided with the pigs and actually popped them, things like that. And play and record type deals. He was like, how are you going to do the interactions with this? I've seen some other people try and do it, and they're like, you're playing a racing game, and they like record all the touches and then try and play that back. That's not going to work. If that does, your game is very boring. If I can beat your game by doing it the exact same way each time, your users are going to hate it. That's just wrong. You have physics engines. You have AI. Your game should change, and your tests have to change with it and actually work. I mean, they're different. The button's not always, I mean, it's just different. It's different than an app. And people just get caught up on this. And I decided to Google a little bit and see what other people are saying and why people aren't testing games. Some of them actually kind of cracked me up. A lot of people are like, we have deadlines. Game developers have deadlines. So app developers. I mean, all this stuff, you can't test for different things. And my favorite was when they're like, game developers are hardcore. We don't need to test. So I'm like, but a lot of it really comes down to there's no tooling. How do you test games? There's nothing out there to really help you out along with that. But you're right. I do agree with you. Those are all really good reasons not to test your games. And followed up by, I told Nat, you're doing it wrong. It's not often you get to tell the CEO that, no, you're thinking about this completely wrong. That's why you can't test games. If you can test an app, you can test a game. It really comes down to that simple fact. You're thinking about it the wrong way. You're right. If you're trying to detect the player, make sure he's not walking through a wall, that's horrible. That's not going to change from one device to another. What is our problems with testing? Gameplay is just not what you're trying to test. One of the games, I did a thing on Monogame the other day, and I showed off my bike game I've been building for years, and I keep scrapping it and starting over because I don't like how the gameplay feels. You as a developer is passionate about this. You know what your game should feel like. I showed off some of my old bikes and the physics, and I was like, that's amazing, you need to use that. I'm like, no, it feels wrong. That's not what I want. You don't need to test that automated. You will do it. You will have testers that you hire to do that type of stuff. And you just don't need to deal with that stuff. A lot of stuff you need to do with is all the stuff you don't want to test. Who wants to go through and load every level? That's boring. You want to play your game. You built it. You're going to play with that type of stuff. So the menu systems are very, very important. If they can't load the different levels, they can't tap on the menu, that's where you're in trouble. That stuff changes from screen resolution to screen resolution. That is where you're going to run into the most of your stuff. In-app purchases, if you can't test that, you're not going to make any money. There's so many things along that way. The screen resolutions. You start moving between the different Android devices. It's amazing when you start seeing all the different resolutions that are available. How is it going to work? Is your menu resized? Does everything resize too small on half the Android devices out there? Are things still touchable? Orientations is a big thing. You don't want to keep there rotating your thing everywhere. Most games are locked into one orientation, so that's not really an issue, but load time and performance is another big thing. You should be able to track this, even while you're developing. As Nat was saying, you should be running Test Cloud on every build. That's how I do it. I don't go run on all devices or the whole suite every time. I run my whole suite on one device every commit. And it doesn't take that many minutes that time, but I realize regressions. You saw those graphs. You see, I just doubled my app size. Did I do something worth doubling my app size? The performance shot through the roof. What did I do? So it's nice to do that stuff regularly on Test Cloud. Of course, like I said, level loading is a good one. Your game state, opening, closing game state, go past most of this stuff. Game restoring, that stuff's important. There's so many little repetitive things like that. One of my favorite tests is to go through and to load every level over and over and over again. Just open and close, open, close. How are you handling this? Can you handle this? Sorry, this just keeps going and going. I thought it was awesome. There's so many little repetitive tasks like that that you don't want to do, no one else wants to do. Test Cloud can do it for you. It's amazing. Whoever got this is just pure gold. So I started Googling on, you can see my Google search result is Android testing devices. That's it. That's the image search results for Android testing. Blown away. Up until iOS, or the iPhone 6, it started to get a little fragmented on iOS, but it wasn't too bad. It's catching up. But seeing what different people's strategies was, I was looking for there was one that someone in China did. They had like a pile. That's what I was looking for. But I was just blown away. The different fragmentations that people are seeing. I mean, that's insane. You can't see those pixels, but each of those pixels is a screen down there. This is the fragmentation you're dealing with, and people's ideas of testing. If that's how many screen resolutions you are, and you're looking at people's things, this doesn't even come close to covering it. Some of these are like pathetic. There's like only like 10 devices in there. That's your testing strategy. You're not getting your coverage. All right, something really important, locale settings. When I change you're not going to test your game in Chinese. You're probably not going to. You're probably never going to switch your phone because you're not going to know how to go back to English. It's just not something you're going to do. As the text expands, I was trying to change an app and make it to where it was had different locale settings and German. The German was so hard because the words were so much longer than the English ones. And I had text overlapping everywhere. Buttons looked horrible. You should not be in charge of having to do that on your own phone and testing all the different locales out there. If you look at this, 4.9 billion, and I got these stats, they're from earlier this year. 4.9 billion in North America. 12.2 billion in Asia. We have one language here. There's so many different languages to deal with in Asia. Jonathan Peppers did a whole talk on how to localize your apps. And some of the stuff they went through is amazing. I was looking through some of their code and if-defs, if China everywhere. It's crazy. You want to have a nice, easy way of doing that. And you can't leave those people out. So let's jump into how do you test a game. Right now, a little bit about architecture with UI test. And the way Test Cloud works. We have our test devices, and we have our test runners. So it's a different machine. They're Linux machines that communicate via USB to the test devices. And all the devices are on Wi-Fi. We don't do cellular. That'd be way too expensive. So Wi-Fi connected, so you have internet connectivity on those. They do not have a firewall. They can connect to whatever they need to. But our Test Cloud, security is huge for us. These little devices, we wipe them out every run sometimes you'll wait, that says preparing device. The device is being wiped and reset and getting set up just for you. You'll never see old data on there. So those devices, they can connect to the world. We're going to reset it afterwards. Do what you want to them. But our test stuff, like I said, security is huge for us. These devices cannot talk. You open up a port on your device, it cannot communicate back and forth between the test runner. So we have our Xamarin UI test in Calabash. That runs on the test server. And then we have our Xamarin Test Cloud agent, which you embed inside of, on iOS, you embed it inside of your app. On Android, we run a test runner side by side of your app. So you have two applications running. One controls the app and does all the testing, or like gets the buttons and things like that. And those actually communicate via USB. So USB is the only way those things can communicate. And of course, then your app communicates. Now, this works great because we have the Xamarin Test Cloud agent. It knows about all the UI. On iOS, it knows what a UI button is. It knows what a view controller is. On Android, it knows what their buttons are and an activity. And it can tell you everything you want to know about that. Well, when was the last time you put multiple real UI elements on a game screen? You're just drawing to OpenGL. There's no reference that's identical across all games, unless you're using a specific framework. But even then, it's still pretty difficult to say, this is a button. You're just drawing a sprite. So how are we going to do that? We can't use the built-in stuff. We can use parts of it, but we can't use all of it. So we write a game server. We write a little game server that runs inside your app. And its job is to communicate back and forth with Calabash, or with the UI test. So that way we can communicate, and I had to write one to make it work. But it's really nice because you know your game. You know what state it's in. You know where the array of your buttons are that you're drawing out. And you're able to quickly and easily interact and return, here's the button. And this is where I think it is. And you find some interesting stuff this way. All right, enough talking. Let's jump into the fun stuff. A little bit about me. I like doing interactive stuff. If you want to see something more or you have questions about anything, stop me. I'm not just going to be in some little canned demo. And if you want something, we'll modify to do what you guys want to see. So let's leave the demo. To do this demo, though, I'm going to be using 3 pieces of software. I will be using Xamarin Studio, MonoDevelop, and Unity. So 3 things going on. Most of the stuff I want to show off, I've done this on Monogame. I was actually trying to get into Battle Pillars last night at midnight so I could show it beating the first level. But I don't know their game. So I couldn't find the play button in their app anywhere. So who doesn't label their play button play? It's ridiculous. All right, so I'm going to be using Xamarin Studio for the test runner. This is going to store, whoa, there we go. This is going to store the tests. This is what's actually going to run the tests on the device. As I said, I have Unity, and I'm going to show off the boring stuff because that's what's important, your menu systems. So I found a menu system. I just went to the Unity asset store and said, searched for a menu system, found this one, and so this is the one we're going to test. OK. Now, on top of that, like I said, I will be using, you'll see it'll look just like Xamarin Studio because they're using a newer version of MonoDevelop now. But it will look very, very similar. So I'll try and make sure I distinguish between the two when we're switching between, because it gets a little confusing. OK, so to do this, if you're going to be doing Unity, I made sure to make it super easy. Unity was a lot harder, by the way. I had Monogame working in like a day. Unity took me like a week. The debugger would never work. I had to console.writeline debug the whole thing, so be warned. So I made a Unity package, so if you are doing Unity, you just double-click on this and it installs it in your game. So let's actually do that. I think I'm starting, yes, this one does not have my server, so nice little Unity package. What that does is it asks me what I want to install. I just say import all of it. Uh-oh, that looks like it's missing stuff. It didn't show the routes, but I think those come in. They better come in. No, they did. We have routes. OK. So a couple different key pieces of this. Like I said, I had to build a game server. And I built a couple base classes to help do this. And I want to show how easy it is. OK, first let's tie this thing in. All I have to do, once I add my stuff, I just have to come in here and say add a component. And I say add one of my scripts. And there is a start test scripts. Throw that in your test runs, delete it when you're done. You can if-def it out, so it'll always run, but I now have testing working in Unity based off that. So it's pretty easy when you jump into this. But let's see how it works. So if I click this play here, you will watch on the console, it will output web server's now running. So it just outputs, you know it's running. It's a very, very basic web server. It runs off of, it's kind of RESTful, kind of not. I hacked it myself, so I made it as RESTful as I wanted to, because that's a lot of work. And all it is an HTTP listener that listens on port 8081. That is key. I'll come back to that later, because as I said, they cannot communicate via Wi-Fi or TCP IP at all. So do all of it over port 81, because we do some weird stuff to send that through the USB. We'll get back to that in a little bit. All right, so scripts. I have a couple of base little things. I have my base element. Here comes monodevelop popping up. The icon's different, makes it a little easy to tell. So it's going to load, and Unity never loads the one you want when you open. So let me try again. There we go. Basic little class. This is going to be our base game element. You probably have something like this already that probably has these same properties. You could use it instead of mine. I just wanted something simple that didn't have all the bunch of extra properties, because I'm going to JSON serialize this back and forth a lot. So even if you have your own convert to this, it's nice and easy. So I give it an ID. Unity doesn't have all the standard system about drawing, so I just grabbed those from Mono and copied them over. So I have pointf, rectangle f, an extra, so you can pass over whatever data you want, just something else to look for, is on screen. That's huge, because you typically will have an instance to your objects, even if they're not on screen. You have them in your scene graph somewhere. And then I have the marked property. They haven't showed this off much in UI test, but I like using their marked. The marked goes through and looks through multiple things. Like if you're looking for text, you can, if it'll look for the text property, it looks for the ID. So you can use, the marked just does lots of things. So I mimicked that. And it just does a check. If the ID contains it, and on my other one I have a game button, it also says if the text, because I added a text property to my buttons. So just a little bit of extra stuff in there. And these are the things that I'm going to use to transport back and forth across the wire. All right. Now let's look at our game server. Game server, HTTP listener, nothing fancy going on here. Port 8081, very, very important. Aside from that, I process some requests. I wanted to make it kind of modular so you can quickly add into it. So I have this router, so you can add routes, similar to like an MVC style, where you're saying this is the route for this, /path, /whatever. And I have a base route, which takes care of all the heavy lifting for you. It takes care of the responses back and forth, subclass it, do whatever you want to it. And then I have a route type T, so it knows what type you're returning, and it automatically does the JSON serializing for you. So if you're game objects, you'd say this route takes a type of an array of game objects. So that way, it just does all the magic for you. You just have to do one method, this get response, that returns that type. And then I take care of all the wire transport stuff for you, so you didn't have to. So let's look at a very, very basic route. The first thing I want to do is make sure that my game's running. So I send a ping to the server from UI test. So I had to add a ping route. Nothing fancy. It returns a Boolean, and you'll notice that for my get response, I just return true. It'd be weird for me to ever return false, so that is my basic route. Now, who's used Unity? I should ask that before I jump into this. Only 1, 2, 3? So, okay, a couple. Unity's different. They wrote their own C#, so you'll see some differences here in how it works. So I have my little Unity routes, which just tells my ping route to enable, and my game objects by type enable, and then my screen route enable. One thing that's nice about their little engine is they have some really nice helpers for me. So if I look at my current screen, because that's something that's important, you want to know what screen am I on. You always have to do everything on the UI thread, everything, and my HTTP server, of course, isn't listing on the UI thread. So I'm using a thing called Loom. Basically, you have one of their little scripts that takes a queue of actions, and it just runs on the game loop. And it says, is there anything to run? OK, fire it, fire it, fire it. Nope, nope, never mind, keep going. So it just fires things on the UI thread for you. There's no invoke on UI thread like you're used to on mobile platforms. So I'm using the Loom, and I was really lazy, so I say, well, while not completed, wait for it to complete. And yes, completed is finally true. So, but they have this application class, so it's static. I'm able to say application loaded level name. That's all I have to do is grab that level name and return it. And so I'm able to write a test and say, wait until I get to my menu screen. Wait until I get to my gameplay screen, because that's important to know. You want to know what screen you're on, and you need to make sure when I tap this button, it actually loads level 1. So I do some checks with that. So that's one route I have. The other route is the most complicated route I have here, and it's one that you'd probably, for your game, build something similar. I have my game objects, find objects by type. You're going to want to say, you know the types in your class. You're going to say, I want to find, in Unity, everything subclass is somewhere along their game element of some sort, or even if you create your own class, they still instantiate it as one of those things. It's kind of like object. So I can always query these things out. And so for this menu system I'm going to show off, they have a menu level icon. These are menu level icons. This is a menu level label or some mad level label, something along those lines. So these are labels, these are the buttons, and I'm able to query for something like this. So to test my menu, I want to say, wait until you see level 1 icon, and then tap level 1 icon. This menu also, you notice, only unlocks when you get far enough along. So I can check to make sure I can't tap on buttons as well. So I use this game type, oops, wrong one. Two IDEs that look the same. It's crazy. All right, so my find objects of type is a route of type T that returns an IEnumerable of game elements. Makes sense? That's what I'm sending across the wire. So it does take a post or a get. I was lazy, let it do both. And I grab out the query string stuff, parse it, do some nice little reflection stuff to reflect through all the assemblies and find out where that type exists so I know what I'm actually looking for to get the actual type object. I keep a cache so I don't have to keep looping through every assembly there is after you've looked for it. So yeah, here's the type, the cache. Eventually, they do have this nice little thing where they have game object, and then I can do find objects of type. So that was really nice having that built in Unity, where I'm able to just search through the entire game looking for objects of a specific type. So that worked out really, really nice for me in this. And all I do is I loop through each of those, and I do this nice little object. I made an extension method. Yes, there's more extensible ways of doing this, but for demo purposes, an extension method is really nice just to transform stuff. And one thing that you want to make sure you do, as you're testing this stuff, you're going to want to make sure that you transform things into screen points. So I grab the GUI elements, and I grab their buttons, and I grab out their rectangles so I know where to tap. One thing you don't want to do is I could programmatically say, tap this button. My web server will tell my game, tap the button and load level. It's kind of not what you want to do. You want to make sure that the game server just responds. Yes, you might use it to set up your test. Please get me to the state. Now I'm going to start running tests. But you want to actually interact through using UI test. You want to make sure that when you tap, because it's identical to tapping on the screen. Where you think your button isn't always where it's actually at. Scaling is fun. We all know how much fun scaling is. So make sure you're actually tapping where you think you are, where you think it should be, because that's what you're going to be checking against in your game. And you'll find that BMX game I showed off in the mono game, the menu's completely broken. You have to click. I'd centered the text, but then I didn't center the object stuff right, so you actually have to tap to the left of the menu to actually start it. But my game logic, yeah, my game logic's looking at it wrong. So that's the type of stuff you can quickly find in Test Cloud, and I broke it when I changed my scaling for the iPhone 6. So it's nice to have those type of things so you find those regressions and they don't creep up and get you later. All right, I'm going to jump over and grab some more predefined stuff. As I said, I'm using this mad level manager, and I have a little snippet of how to grab all of the mad level stuff out. Just going to, it's a lot of code to write. It's a lot of transforms. So it jumps in, and let's just replace this right here. I didn't include that in the package because I figured most of you guys don't want all of the generic stuff that won't build. So I go through, and to do my 2 elements, I'm doing it really easy. I just cast the object as what I hope it is if it returns null. And this also gives you a way to prioritize what they should be. But with my mad level icon, I'm able to get the screen's rectangle and figure out where it's at, which lets me know whether it's on screen or not, because that menu knows about every icon. 100 levels, it returns all of them. So I could also make it to where it only queries the ones that are on screen, which should only be those 9. So, sorry, there's a lot of setup to this because it's not meant to do this. But this is really powerful because I have full control over what I'm returning, what I'm testing, and we've built this for you for UI stuff, just not for games. So I'll be pushing out pushing all this code out so you guys can see it and learn from it and modify it for your stuff. And along the same lines, I did the same thing with the mad text though, and it just grabs out the name. And you notice my get to screen rect. It's just grabbing the camera, doing all the transforms to figure out where it thinks the touch point is on screen. And the guy who wrote this level editor actually gave me the code, and it was wrong at first. It worked great on a couple devices, but the moment I put it on the test cloud, it only worked on like 3 devices. So it's kind of funny. I'm like, wow, so I'm having issues. And he's like, oh, you want to use this different camera. And even in Unity, which takes care of a lot of that scaling and issues for you, depending on which camera and transform you use, you can easily mess up touches to world points. So as you can see, that's quite a bit of code just to figure out where the rectangle is and if it's on screen. So it's tricky. Games are tricky, tricky stuff. And of course, I then spit it out to a rectangle F. All right, I think we're through the setup. Now that I have this embedded in this demo, or inside of here, I can deploy this to my app, or to my phone, and it builds a server and runs it. Now let's go look at a test, though, on how to actually interact with these things. So you'll notice in my test fixture, I'll just scroll in this way. I added in the same exact button and game element because I need to be able to serialize those back out. And in UI test, you use the iApp, which is an Android app or an iOS app. I created a Unity app. It is not the same interface. It has a lot of the same, I kept the same style, but when you initialize it, you pass in the iApp, and locally, you have to pass the IP. There's no way for me to get what IP address it is. Actually, my phones, these are on different Wi-Fis. I'm not going to actually be able to connect to them. Oh, well. So that's all right. We have test cloud runs. So you connect over IP to it locally because the routing, like I said, the USB routing stuff happens through test cloud. Now, to do that routing, just a really quick, all this thing has is an HTTP client, and it's just making a bunch of get and post. I mean, everyone's seen that code from an HTTP client. Posts or gets, and I just serialize the data back to whatever type you're expecting. Nothing magical or fancy there. The real magic for this comes from when I set this thing up, I have this method where I check, is it test cloud? There's environment variables to know whether or not you're running on test cloud. If you're on test cloud, this method returns 1, a string of 1. So if I'm on test cloud, I need to go and get Xamarin Test Cloud app endpoint. This will forward all of that 80, 81 traffic via USB. So if you don't use that, none of your tests will work on test cloud. So very, very important step there. And then I'm just doing web requests back and forth and communicating. So let's look at some tests. These tests were fun. So this is whatever my phone always got at home, or I'd switch to localhost. I have little things in there. But I instantiate my app, same way you would. You do configure app, Android, pass in the APK file. Nothing fancy is really going on there. This is all stuff we've all done. Actually, I'm going to try running it. Let's live dangerously. All right. I'm going to run my load level test, see if this runs while we're walking this through. Nope, I already got an error. Oh, and the IPs would be wrong anyway. I have an activated test cloud on my app. That is awesome. Unable to run on a physical device without activation. Someone should get me a code. Okay, so I can't run those anyway right now. But activate your test cloud so that way you can run it locally. I just upgraded to the latest NuGet last night, and I didn't even think about that. All right, well, anyway, we can still look at it and see how it works. So I have an app for wait screen. And all that's doing is you can never guess which route it's calling. It's calling that current screen. I just pass and say, wait till I'm on my grid example touch scene. And if we jump over to Unity, and I jump into my scenes, you'll notice I have grid, example, touch scene. You can't read that because it's really tiny and I don't know how to suit. It just pulls back whatever scene's loaded. So I'm able to do a one-to-one mapping from the name of the class to what I'm looking for. And that's whatever Unity returns in the app.current scene. I don't remember that property was named. But it returns that. And then I also have the level. If I double click, don't save. Oh, I should have saved. So this is the level for the sample. So that way you just choose how many stars you got for winning the level. So it just goes to the level. So I can write my tests. And this one is called Mad Level Tester, as you see. And it makes it easy. So now I can do app.waitForScreen. Nothing fancy going on in here. I'm using this built-in UI test wait for. And I just keep checking, is the current screen equal to the name I'm looking for, with a timeout of 500 milliseconds. Oh, that's the retry frequency, sorry. I try every half a second. You can increase that, decrease it, whatever you want. But I check every half a second for up to 8 seconds for that screen. And I actually ran into loading, not on this one, when I was doing this with another one, I was running into load times on some of the older devices. So it's interesting seeing with the timeout of 8 seconds, that's a long time for someone to be waiting for a level to load. So it's kind of, I was blown away at, wow, I had to increase the timeout on some of the stuff. So really interesting to see that. All right, now what I'm doing is I say app.getElementsOfType. I jump into there, and it just does the same exact thing. Post game elements. I say hit that route, and I pass in, for this type, I pass it in as a query parameter of type. That's how I transfer the type back and forth. And like magic, out comes an array of elements. I just keep checking. As long as it's not null, wait for it to be null, then return the elements. Really, really basic. I wish I could show you this running because you see all 19 of them come back. And I'm able to, and at first I didn't realize all 19 would come back. So I started, oh, yes?
It's pretty easy. If you just create an XTC API key file, log into Test Cloud, and you can get your activation key.
OK, I'm logged in. Yes, yes, yes. Application not responding. That's my test runs. That's awesome. OK. That's right. We'll go to test runs in a minute. I give up. OK, that's all right. I'll deal with that stuff later. Sorry, I ruined my demo. I apologize. But either way, you can run this later yourselves because I'm going to push this code out. And I'll fix this, and you can come look. We can go over it and look at it. I can explain any of it after my session's over. So I'll fix that soon. All right. So load the tests. App.screenshot. Same thing you're doing from UI test, saying take a screenshot. These are the steps along the way on your test cloud. And I also added in, when you're doing wait for screen, I gave an optional screenshot. So sometimes you don't want to make 2 calls. I'm lazy. So an overload to tell it to take a screenshot as well. And I go and I tap, let me get Chrome working, because this is where I actually need to go restore. Yes, it reloaded. So let's just jump through some of these old test runs. All right, so we have our test run here. Let's dock these. Do you know there's a docking program that does the same Windows 8 docking on Mac? Awesome. I can't remember what it's called right now, though. So ask me afterwards. All right. What was that? No, it's something for it's some dock utility, but it lets you. Yes, that is awesome. Okay, so I docked these windows so we can see the test cloud. Are you kidding? It's Mobizen is. Chrome has not updated for Yosemite yet, and you run into spinning wheels once in a while. All right, well, we'll look at this portion right now. Let's get this out of the way. Let's get this out of the way so we can see our test. And let me restart Chrome one last time. Close that. Hey, there we go. Restore. Close that one before it freezes us. All right. That's what I was going to be using to show my Android on the screen, but not needed now. Not needed. So on this one is our icon count test. So let's find that one. It's the first one, icon count. So I do app.waitForScreen. Actually, I'm going to jump back a little bit. So this is a landscape menu. And I ran it landscape. Every time I tested it, I was using it in landscape, and it worked great, and it was always this way. When I first ran it on Test Cloud, do you guys know the default orientation of all the devices in Test Cloud? They're all sitting portrait. You can tell it to change that, but when I did some of my older test runs, nope, not that one. Let's go back a bit. So I did some of my older test runs, and I was checking how many icons were on the screen. You can see what happened here. That's not good. And if you look really close, you'll see there's a line there. Those menu icons were overlapping. Now, what's even crazier is I don't have a test showing this, and I was going to show it live. If you rotate landscape, it didn't fix. Those orientations, those buttons stayed where they were, overlapping each other. Not a common use case, not something that you're going to do in most cases. You're probably going to lock it to landscape or portrait, and this is sample code, so I'm not mocking the guy for doing it this way. It's just a sample that he ships with, but I instantly found a bug as soon as I threw it on Test Cloud that I didn't find through all my testing locally. I didn't even think about it. It was a menu. I knew I was landscape. And little things like that throughout your game are so easy to overlook. And the moment I threw it on here, so then I wrote a test to make sure I only have 9 icons on screen, and it fails in portrait, which is kind of crazy. All right, put this back over. Let's go to this test run. So we'll go by step and see how this test run runs. So my icon count in portrait goes through. Test runs are fun to actually look at. You can see all of these running, and I grabbed, what's interesting is you'll notice some of these are in different states. So this one, notice how much bigger that button is than this one. Now, if you come to my test, I threw a 1-second sleep in once the screen showed up. So the screen loaded, Unity says I'm loading it right now, that's when it responds. I say, wait a second, because that was typically how long it took for all those to animate in. On some of these older or some of these other devices, this is an S3. From the time it says the level's loaded to the time the animation's finished was a lot longer than some of these other devices. So it's kind of interesting. I'm not sure if it had longer load times or what was going on, but it was in a different state. So I should probably put my sleeps out a little bit longer for my tests, but it's interesting seeing how some of these other devices were a lot faster and loaded. And especially when I start switching levels, I had them in weird states across all these devices. So very, very basic test. Make sure it loads, and make sure that we have 9 icons. Really pretty simple test. Of course, then we jump into the fun ones where you jump in, you tap on a level. So menu loads, tap on a level. And all of these, most of these failed on the landscape, or portrait, because you couldn't tap on some of the buttons because things were overlapping. And has 50 points, back menu. Of course, why aren't these? Internet I'm clicking faster than the internet. Sorry, I need to slow down. So, all right. Test Cloud's going slower. Let's jump over to code then. So there's a lot of really powerful things you can do with this. A lot of this also does apply to your real apps. There's times, for one of my tests for my music app, I actually am watching a progress bar to make sure the downloads are going far enough along and make sure that the song's playing. There's a lot of times you want to actually check the data in your app. You can use the same exact server I wrote here, embed it in any of your apps, enterprise apps at all, and you can now query your database. So you say you inserted the data, you can now query using UI test and make sure it actually inserted the data you wanted it to. You can, at this point, set your app up into any state you want, and really make sure what you're saying is happening happens. So it's pretty cool and really powerful. I did go through, like I said, make a couple basic tests, make sure I should look for the icons. I make sure when I go to the other screen, it actually does the right screen name, and I can tap. I look for the button called lower one. I tap on it. I added the same tap method that takes these game elements. It just looks where it's rect and taps on it. So you can do pretty much anything you can do in the UI test with the game stuff right now, as long as you build the server portion yourself. And I don't know how your game's architected, as I ran into with Battle Pillars. I can't write a generic thing, but it's close enough to where you can quickly and easily throw this stuff into any game. So Unity was harder, so that's why I showed that off the most. But yeah, it's nice and easy. All right, any questions or anything you guys want to see? No questions. All right. Oh, yes.
So I noticed that you're building a lot of the client server stuff from scratch there. I apologize.
Mm-hmm.
At the beginning,
Yeah.
you showed something else before. Aren't there like is there anything else around there if we're trying to sort of
Absolutely. No.
Calabash,
Yeah, absolutely. So the question was, are there any other frameworks so you don't have to write your own like I did? Yes. The biggest thing is, though, you're still going to be doing the server and teaching the server about your games no matter what. But you still have that app-server relationship out of the box. Selenium is one that I've seen people do or try. But you still have to teach Selenium what your game objects are, how to even query those things.
Or I guess more like, if something was, say, instrumenting your app with server functionality rather than you sort of needing to inject server code into your...
If you have, yeah, so you don't have, so the question was, is there anything you don't have to inject? So you don't have to inject your own, is there something already running in there? Really, a lot of it comes down to how segregated, I talked about how segregated devices are. You can't do IP, they can't communicate. Our devices and our test runners cannot communicate, except via USB. So if you put it over the port 8081 or that environment variable I showed off, then it'll let you communicate via USB. So if you put your stuff on there, yes. But either way, you're going to, technically on iOS, you can use Calabash completely. You don't need to use mine at all. For Calabash, we use Frankly as a server that's built in, so you can just inject into theirs. That was my first demo I did. I just built a Frankly route, injected it in, and then I used UI test to manually invoke those routes. And it worked perfectly. So that's how you can do it. It works, but that doesn't work on Android. What are you going to do on Android? So I did this route because then it's cross-platform. So it's up to you on how you want to do it. I'm going to push this code out there. It's very basic. I mean, little web server. Sorry? As I described about the architecture, on Calabash, oh, sorry, so why doesn't it work on Android? On Calabash, you don't embed Calabash into your Android app. We can take any app from the App Store and just test it right now. We run an app side by side, and it queries into your app. So you have no way of even communicating with this other app. You know nothing about it. Your app doesn't. Whereas on iOS, due to all the AOT issues, you have to actually build the server into it. So the server's already sitting there. You just inject in, you take it over. It's really easy to do. I actually had them include the headers to do it because it's so easy. Yes?
Are there any plans to kind of like enhance Cocoa Sharp so some of the stuff's just built in?
Wait, are there any plans for what?
To build some of this into Cocoa Sharp. I mean, it makes sense at that point in time to just say that
So, yeah, question was, do we have any plans to build this right into Cocoa Sharp? As of right now, game testing wasn't on our immediate plan. Like I said, I was told no when I actually asked to do it a few months ago. So typically, a lot of the things that I hack eventually make it into a product somewhere. That's kind of the route we like to go. The video recording was a hack I did for the Test Cloud. So it all comes eventually from a little prototype of something, slowly moves its way in. Traditionally, I can't guarantee that on this or where it's going, but it would be nice, I agree, to build a Cocoa Sharp one. Because they have a menu system, and we can just interact with those. Agreed. It would be nice to do that, and I should probably talk to Mike Bluestein about that, or Kenneth, because he's the one running that stuff. So, any other questions? All right. Well, if you want to see it live demo, I can actually activate my stuff. That's what I get for updating everything at midnight last night. I know better, but I do it anyway. So I'll activate everything, and then we can show it off outside if you're interested. So, all right. Thanks, everyone.